So this question here, we have a rational function, and we want to find the vertical and horizontal asymptotes, the local min and max, and the concavity. So we need a second derivative here. So first thing is we're looking at this and looking at the numerator. The numerator is an e to the x function, and e to the x function has no zeros. Okay, so this function does not cross the x-axis. Looking at the denominator, I'm going to get a vertical asymptote. And I can kind of see that my vertical asymptote is going to be at -1. Okay, so drawing in my vertical asymptote at -1. -1. And I can see that if I approach -1 from the negative side, that means I'm going to have a number less than -1, so like -1.1. That's going to give me negative in the denominator. So if I approach it from the negative side, it's going to go towards -0. So dividing by 0 gives me the infinity, and I'm going to be going down to that asymptote. Okay. So looking at it from the right-hand side, as I approach -1 from the positive side, for example, -0.99, that's going to give me positive in the denominator. So I'm approaching 0 from the positive side. Again, dividing by 0 gives me infinity. From the positive side, positive 0 is going to, from the sign analysis, is going to give me positive infinity. Okay, so on this side, it looks like it's going to go up towards the asymptote. Looking at the horizontal asymptotes, it is endpoint behavior. So we want to see what's happening as x gets really, really big, as x goes to infinity. So we're going to do those limits. And as x goes to positive infinity, we're going to end up with a really big infinity over a small infinity. This is strong over weak. Okay, so that's going to go to infinity. So what's going to end up happening on this side is just going to kind of go shooting off like that. On the negative side, as we go to negative infinity, now this is a little bit different because e to the negative infinity really tends towards 0. And we end up with negative infinity on bottom. So we end up with 0 over negative infinity. So that's really just 0. And we don't really need to know this, but it's actually 0 from the negative side. So as we go out to negative infinity this way, it's going to approach 0. The horizontal asymptote is 0. It's actually going to approach it from the negative side. And we can actually see this from our graph because the only way for the yellow and the red part to connect is if it doesn't cross the x-axis. So we know that that must be the case. Okay, we don't have any place where this graph actually crosses the x-axis. Okay, so we want to have some, we want the local min and max, so we need a derivative here. So we're going to get a derivative. So our first derivative is going to look like this, f prime of x. That's going to give us e to the x times the denominator minus e to the x times the derivative of the denominator, and then that's all over x plus 1 all squared. Okay, we can simplify this. We end up with x e to the x plus e to the x minus e to the x. Those e to the x's cancel out, and we end up with x plus 1 all squared. Okay, so this works out to be x e to the x all over x plus 1 all squared. So we have an undefined slope at -1, and at 0, we're going to have a 0 slope. Okay, and e to the x is not equal to 0, so we don't have to worry about any other points where we get 0. So we're going to have a horizontal tangent there. I'm just going to plug in my coordinate. At x is 0, okay, plugging in x is 0 into that equation, I get e to the 0, which is 1, over 0 plus 1, which is 1. So I have a coordinate at 0, 1. Okay, and that is either a local min or a local max. So we should check our slopes. So I'm going to do a slope check here. So f prime, let's try -2. That's going to give me negative in the numerator. The denominator is always positive. So that's going to give me a negative slope through here. Okay, and that's kind of what it's looking like with what I've drawn in so far. We have on the other side of -1, so let's try -0.5. When I plug -0.5 into there, again, I get -0.5 times e is always positive. E to the x is always positive. The denominator is always positive. So it looks like it's going to be sloping down through here. So it looks like that's correct. Based on my vertical asymptote direction, it looks to be to confirm this. So it looks like this is a local min. And then I just need to make sure I check the slope on the other side there. So I'm going to check the slope at +1. +1, we get positive, positive, positive. So that's going to give me positive slope. Okay, so again, I can plug in the number and actually work out the value, but really I just need to know if that value ends up being positive or negative. And I'm just doing sign analysis in here because I know that this is +1, that's positive, and anything squared is positive. So when I plug it into the derivative, I know I'm going to end up with a positive slope for x equals 1. So that is a local min. And basically, I can figure out what this looks like based on that. Okay, now I'm going to check for a concavity change here before we draw it all in. So I'm going to need a second derivative here. So I'm going to look at the second derivative of this. Okay, so this is going to be, I'll do this in the next video, but we will look for a second derivative.